Hi everyone. Okay, so we're moving. We're going to be starting with sum of angles at a point today. So that's a continuation of the course, sum of angles at a point. Okay? Now, it is going to be very helpful for you to remember the sum of angles in a circle for you to do this. If you remember, for a circle, you have 360. Sum of angles in a circle is 360. Now, basically, what this sum of angles at a point is kind of like an extension of sum of angles in a circle. So if you know the sum of angles in a circle, just peel away the circumference of the circle and you have just a single point at the middle. That's the center of the circle. So that's basically what this one is about. Okay, let's try to draw a circle and see what I'm talking about. Okay, let's assume you have the center of the circle and you have a circle over here. And don't mind the way my circle looks. Okay, and then for this circle, we have, okay, this is a radius here, another radius over here, yet another one here. Okay, looking good. Now, for this, maybe this angle is A, this angle over here is B, that is the angle between this radius and this radius is A, which means the angle for this sector, that is this area bounded by two circles and a chord, is what? A. Okay, then we have here is B, and the third angle is going to be what? Is going to be C. So let's say that is C. No problem. Now imagine what happens if we peel away the circle. Just peel away the circumference, this line, this circular line around the circle, that thing that makes it a circle. What does it look like? So let's see what the thing looks like after we peel away the circle. Okay, so it's going to look exactly like this. So you have something like this. You have the center of the circle here, you have this, and you have this. That's basically what you have left. I hope you understand. Okay, it is basically a development from sum of angles in a circle. So sum of angles in a circle, if you remember, so sum of angles in a circle is equal to what? 360 degrees. Exactly the same way that you are going to have it in here. So what does that mean? That means A plus B plus C, which means the total number of angles in this circle, the first angle is A, because there are three angles here. The second angle is B, the third angle is C. So if you add everything together, it's going to be equal to 360 degrees. Exactly the same way for this. If you are going around in a circle in measuring angles about a single point, let's say you have an angle here, so let's call this 120 degrees. Okay, you have another angle here, let's call it A. Then you have a third angle here, let's call it another 120 degrees. Okay, so what do you have? It means you are given two angles, it remains just one. And remember, for all these things, especially the ones that involve direct calculations, you will be left with just one variable. If you remember the time we did sum of angles on a straight line, if you are given different angles, all of them on a straight line with different dividing lines on that straight line, only one of them will be a variable. Only one of them will not be given. Other ones will be given, just one will not be given. Okay? So the same thing goes for this. You have been given three different angles. One, you have the value for two of them, the value for the first one, the value for the second one, and the third one, you don't have the value for it. So you're asked to calculate that. So what are you going to do? All you need to check, first of all, is to see, okay, the first one goes this way. It is understood. Okay, the second one goes this way. If you are to go through all the angles, it looks like a circle. See, one, okay, you get to this place, you get to this place, you get to this place. That's a circle. That should allow you to know that they are talking about, this is going to be sum of angles at a point, which is basically sum of angles in a circle. Just allow that to be a reminder in your mind. It is going to be sum of angles in a circle, which is sum of angles at a point. Okay, they are basically the same thing. Sum of angle at a point is basically a circle that has its circumference peeled away. That's all. Okay, so if that is it, let's try to solve this based on that principle. Okay, So we have A plus 120 degrees plus 120 degrees. Okay? Everything equals to what? 360 degrees. So what is the reason? Sum of angles at a point equals 360 degrees. So that's the reason. Okay? Perfect. Let's continue. So we have A plus 120 degrees plus 120 degrees. That gives us what? That gives us 240 degrees. Okay? So 240 degrees equals what? 360 degrees. So we can continue. Okay? Let's proceed. Okay, let's continue. So with that, we have A going to be equal to 360 degrees minus 240 degrees. And what do you have as A? Is going to be equal to 120 degrees, which means 3 different 120 degrees. You have all around a circle or all around a single point, whatever the case may be. I told you they are kind of synonymous, okay? Angle is in a circle and angle at a point, basically the same thing. You just have the circumference of the circle peeled away to get angles at a point. That's all. Okay? So which means, what if you add 120 degrees plus 120 degrees and 120 degrees? It's going to be equal to 360 degrees, which is exactly what we said here. 360 degrees, that's the total sum of angles at a point. And that is how you deal with that. Okay? Now, let's have another example. So let's have example 2. Okay. And with example 2, you have to realize that this time around, most of the questions starting from this point are not just going to be they're not just going to be solvable by only one method. That's what it means. Okay. So there are certain questions that can be solved with both sum of angles at a point, vertically opposite angles being equal, and also sum of angles at a point. In fact, by the time we do all those, the remaining versions of all these theories, for example, like alternate angles being equal and corresponding angles being equal, you are going to realize that many of these things are interwoven. So if you are going to be solving a complex questions, which you are going to encounter a lot, you will find some of these things inside the same question. Find like about 3 different ways of solving it, and that makes it more interesting because you don't have to rely on only just one method of solving. So it is now your duty to calm down, look at the question, consider the different ways that the question can be solved, and then go on with the method that best suits you to solve the question. That's what it's going to be. So we're going to see an example of that in this second question. Okay? Now, example 2. So let's say for whatever reason, this is going to be a little bit easy. I want to make it slightly easy for everyone. Okay, so let's say for whatever reason, you are given a question like this. Okay, you have the center here, the origin here. Okay, you have this going this way. Okay, then you have this coming down this way. Okay, and then you have this going up this way. Okay, everything is looking interesting. Perfect, right? Now, and you are given this place to be equal to what? 60 degrees. That is 60 degrees over there. Now, the angle here is given as A. Nobody knows. They're asking you to find that eventually, okay? So now, no problem. They are giving you, please look for the angle here. No problem. Let's see what we can do. And after that, the angle here is given as what? As B. And then the third angle here is given as what? This angle is given as 120 degrees. So you can see what we have over here. Given 1, 2, 3, 4 different angles, and out of those 4 different angles, 2 angles are not given in value. So you have 4 angles, 2 are given, the values of 2 are given. The values of the other two are not given. So you are supposed to find this, and you can find this with different methods. Okay, you could use sum of angles at a point, and you can also use sum of angles on a straight line. You can do that with this question. You can. The only thing that's not going to work in this question is vertically opposite angles are equal. That's not going to work here. Okay, that is definitely not going to work. Okay, now let's see what we can do if we want to solve this question. So let's have the very first one. Okay, solving with sum of angles on a straight line, right? On a straight line. So we want to use that first method. So how do we do that if we want to solve with sum of angles on a straight line? No problem. You have to realize that this is on the major straight line here. Okay? It continues. This, if you are going to be using sum of angles on a straight line, this is basically just a divider. It is dividing the total angles on this side of that straight line. Okay? The total number of angles on this side of the straight line, of course, sum of angles on the straight line is going to be equal to 180. So no problem, but this is dividing the 180 into two different angles. The first one is 60 degrees given to you. The second one is not given. So you figure out how to get that. No problem. The same thing goes on for here, this other side of the angle, this other side of what? Of the straight line. So two angles on this straight line. The total number of angles on the straight line from the theory means 180 degrees. They have given you 120 degrees out of that. The other one is not given. You are supposed to find that. Okay? So let's continue. Let's try to find A. So for the first part of this straight line, the right side of the straight line, we can go with, okay, A and 60. They are the total number of angles on this side of the straight line. On this side of the straight line. Okay, so we can go with A plus 60 degrees equals to what? 180 degrees. So sum of angles on what? On a straight line. So on a straight line. No problem. Then after that, we have A equals to 180 degrees minus 60 degrees. So what do we have? You have A is going to be equal to what? 120 degrees. So it makes sense. Remember, if you add 60 and 120 degrees, it is equal to what? 180 degrees. That is the sum of angles on the straight line. This side of the straight line. We have solved the first side of the straight line. The second side of the straight line, the left side of this straight line, now is what we are going to solve to get B. We have gotten A. Can you see we are using sum of angles on the straight line? We are going to also use sum of angles at a point to solve the same question. Okay? So we are going to see. That's actually going to be like a hybrid of solving the question. Okay? So therefore, because A equals to what? 120 degrees. Let's try to get B. Okay? So let's go over and try to get B. So to get B, we have B plus, again, we can go back to the question to see it. It's going to be B, because this is the other side of the straight line. This is the straight line. So this whole side on that straight line, B and 120 degrees. They are the two angles on that straight line that will be equal to 180 degrees. Okay, so let's continue. So we have B plus what? 120 degrees equals to what? 180 degrees. The same reason, sum of angles on the straight line. Okay. Looking good, right? Okay, let's continue. So which means we have B being equal to 180 degrees minus 120 degrees. By the time you do this subtraction, you are going to end up with B equals to what? 60 degrees. So therefore, B equals to what? 60 degrees. 60 looking a little bit funny over there. Okay, so 60 degrees. If you add 60 degrees to 120 degrees, you get 180 degrees, which is the total sum of angles on the left side of the straight line. Sum of angles on a straight line, we have just one major straight line. There are angles on the right side of that straight line. There are angles on the left side of that straight line. Pay attention to the on that left side of the straight line. The angles on the right side of the straight line, the angles on the left side of the straight line. So with the same straight line, we can carry out angles on the straight line 2 times. Okay? So that's basically what it is. Because on the right side of the straight line, we have just one variable. You can see? On the right side of the straight line, over here, just one variable. One given, one not given. Only one is not given. So it's easy to solve. The left side of the straight line, we have two different angles. One is given, the other one is not given. Easy to solve. So no problem. With this, we have been able to solve for A and B. Problem solved, right? Let's now see how we can solve it using angles at a point. Sum of angles at a point. Okay. The only tiny issue there is that for sum of angles at a point, because this particular question has 2 unknown variables, we cannot just use only sum of angles at a point. Because remember, I told you, any of these questions, you should have just one variable left. So you can try to narrow down this question to just one variable with sum of angles at on a straight line. So you solve the first one, get A. Or if you prefer, you can solve the first one and get B. Then after getting one of those variables, then you use sum of angles on what? On a point to solve the third one. Okay? That's what you are going to do. So let's say we have already gotten A to be equal to 120 degrees. Let's try to get B with what? Sum of angles at a point. Let's see if we can do that and get the same answer that we got here for B. Okay, so let me write it over here. To get B with sum of angles at a point. Okay, I'm going to now write it here. Recall, A is already equal to what? A is already equal to 120 degrees. So let us try to draw the diagram here again and see if we can solve it with sum of angles at a point. Okay, so let's draw the diagram again of that question. Okay, so we have this. Then we have a dividing line here. Okay, so this is the diagram. Okay, 120A, so 120 degrees. We have A here, which is now equal to what? 120 degrees also. Okay, in the question, here is 60 degrees, and here is B that we don't know. So with this now, we have been able to use sum of angles on a straight line to narrow down the question to just only one variable left, just B left. We have solved for A, it is only one variable left. So we can use sum of angles at a point to finish off this question based on this. Okay, let's see what we can do. So what do? Because let's say you are starting from here. Okay, remember, make it look like, if the thing looks like a circle, then you use sum of angle on the straight line. At a point. So you start from here. Okay, the first one, it curves like this. It continues, curves again, continues, curves again, continues, curves again, back to the starting point. So it goes around like this. So you know that what? This can fit sum of angles at what? At a point. So long as you're only having one variable left to solve for. The thing goes around in a circle, then it can fit sum of angles at a point. So let us do that. So we have B plus 60 degrees plus, of course, this A has become 120 degrees here, so we just write 120 degrees plus the other 120 degrees here. So you write out all of them if you are doing sum of angles at a point. This is the point. Sum of angles about a point, so all of them like that. Okay, so equals what? 360 degrees. Okay, because sum of angles at a point. Okay, so then you write what? Sum of angles at a point. So let us continue. So with that, we have B plus, so if you try to add up all these different things, so 120 plus 120, that's 240. So now, if you have done that, then you add 60 to it, it is going to become 300. 120 plus 120, 240 plus 60, it becomes what? 300 degrees. So it means we are left with just what? B plus 300 degrees equals to what? 360 degrees. I guess you understand. Now, what do we do? So we have B equals to what? 360 degrees minus, by the time this crosses the equal to sign, becomes negative, okay? 300 degrees. So with that, we have B to be equal to what? 360 minus 300 degrees, it becomes 60 degrees. That's all. So with sum of angles at a point, we are able to solve B as exactly the same thing we got it to be when we use sum of angles on a straight line. Again, for sum of angles at a point, always pay attention to this. Make sure that the thing, if you are tracing all the angles, try to see if everything goes around in a complete circle. So let's say you're starting from 60 degrees again, okay? It goes like this, okay? You can see it goes this way again, goes this way, goes this way, it goes all around in a circle. Then you know that sum of angles at a point will work, as long as you have just one variable left. It could not work before we got A, because we had two variables at the beginning. So that's why we solved for A with sum of angles on a straight line to begin with. Sum of angles on a straight line to solve that. This thing was actually a straight line in the question. It's a straight line, it's a continuation of a straight line. It is not broken on anything. It's a straight line. So on this side of the straight line, we solved for A. And after we did that, then we did something here to solve for B using sum of angles at a point going around. Okay, you can see that there are multiple ways for you to solve the same question under this topic. By practicing and practicing and practicing, you get to understand and you get to see instantly. You see the question, you get to see what type of method is going to be most useful and is going to be most time saving in solving that question. So that's what I just wanted to pay attention to. So thank you very much. We'll be seeing you in the next video. That is going to be corresponding angles. Corresponding angles are going to be treated in the next video. Thank you so much. Make sure you subscribe to the channel, like the video, and bye.